Hello everybody, this is part 2 for the integration questions, and today we're going to solve a few more integration questions, and with addition to the normal integration questions, we're also going to start a few questions based on matrices and determinants, another quite interesting chapter. So join me in this journey, and few questions which I'm going to start today. I haven't tried them out, so it's going to be interesting to see how we develop solutions. So, first question is integral x plus 1 whole divided by x into 1 plus x e power x whole square dx. Okay, so if you've seen my previous video, I always say if this term would be some form of n, so I could have just written integral x plus 1 by n, which is nothing but 1 by n integral of x plus 1, and this is something we know, right? So let us try to condense the denominator into a much better and viewable form to work up with. So what I'm going to do is I'm going to consider this as t. The rule I'm following is the method of substitution. Right, so as I follow t, I preferably hope that after using t, I'm going to convert dx in terms of dt via manipulation, and once we're done with it, I hope to convert this whole form into a much better and a simplifiable form so we can develop our solution with. So let us try doing that first. So 1 plus x e power x, we considered t. Okay, so as I want to develop dx into dt, we're gonna differentiate both sides. So d by dx of 1 plus x e power x equal to dt. Right, so let's just derivate our function here. Derivative of a constant is 0, and derivative of x e power x is an interesting one. So for those who don't know, u into v's, u and v are two terms. Differentiation is going to be v u dash plus u v dash. So by the term dash, I mean d by dx of u, that is the derivative of u. So if you've noted down this, I'll slide on to the next page. So integral x plus 1 by x into 1 plus x e power x whole square is our integral, and let us continue derivating it. So using the UV rule for x e power x, we get so d by dx of 1 is 0, and x into derivative of e power x is e power x plus e power x into derivative of x is 1 whole dx is equal to dt. Right? So dx in terms of dt will be dx is equal to dt over, let us take e power x common here, so it's e power x plus 1. Now if you've realized, this is quite handy because our numerator has x plus 1. So it's going to be quite easy to simplify the term, as the x plus 1 term is going to get cancelled out, right? So I'm quite happy about this one. So let us continue the solution. And let us substitute our dx and our t into the main equation of ours. So integral x plus 1 over x plus x e power x is t, so it's going to be t square into dx is dt by e power x into x plus 1. So this gets cancelled out and this gets cancelled out, leaving us with dt by x e power x into t square. And that's again something good, because we had earlier taken x e power x plus 1 as t, right? So according to this formula of ours, x e power x is nothing but t minus 1. So continuing this, we get integral dt, and I'll supposedly write a much better version of this now, x into t square, which is nothing but the integral of dt by t square into t minus 1. Now the integral we've just obtained, let us name it as I of x. So there is a common rule that whenever we have a term that's like integral x by y, where y is often a quadratic, and x is a linear term, we can write the linear term as L, where L is a linear term, equal to lambda, a constant, d by dx of q, that's the derivative of q, plus du of q. But this does not work here, because here there is no linear term, and rather the numerator is actually a constant. So as this rule won't work here, we're gonna slightly alter our traditional approach. So what I'm gonna do here is just add t minus 1 and subtract 3 such that I get a 1 here again. So just look at how I do it. So t plus t minus 1 by square to t minus 1. Now as you can see, I can actually break this integral into two halves. So one will be this integral. So one will be this integral, and the other will be the negative this integral. So let us continue developing our solution. So integral t over t square into t minus 1 minus the integral t minus 1 over t square into t minus 1. Okay, so our integral will now be t and t gets cancelled out, so it's integral 1 by t into t minus 1 minus t minus 1 gets cancelled out, so minus integral t to the power minus 2. So well, we can again use the same method to actually simplify this. We can also use the substitution and put t minus 1 as u. Thus, if we do that, what we're going to get, it's going to be something like integral 1 by t into u. And as I've put t minus 1 as u, dt will be equal to du, right? So du. And if t minus 1 is u, t is u plus 1. So integral u square plus u. You can similarly use the technique I've shown above and get the answer quite easily. We'll try developing the solution for this integral using the similar technique, and I'll wait for a few seconds and try it out on your own until I develop the solution again. If you haven't already figured out, as you did t minus 1 here, same thing will apply here. And the thing you're going to get here now again is going to be, and after doing it similarly, we're going to get integral 1 over 1 minus t plus 1 over t plus 1 over t square dt, and using the formula x power n integral x power n is equal to x power n plus 1 by n, you can easily simplify the above expression, and the final expression we're going to get will be log of 1 plus x e power x. That's it. You're going to get x e power x after substituting the value of t in the final integral, right? So over x e power x, that is nothing but our t minus 1. Minus 1 by t, that is minus 1 by 1 plus x e power x. Plus the constant of integration. So this will be our final answer. Hope you liked the integral. Even I am quite surprised of how it turned out. So give me 1 minute until I find another question to solve. Alright, so the next question will be integral of dx over x minus 1 to the power 3 by 2 and x minus 2 to the power 1 half. Well, this might seem quite intimidating to solve, there is quite a good trick to how can I actually solve this problem. So again, as you can see, like most of our integrals, Again, the denominator is our problem. Set that I had integral dx. Again, just write it as x, or use the simple form that we've already known. So how do we actually make this expression into a much beautiful one? So one thing we can do is we take, let us generalize this term like dx into a into b. A and b are just the terms we have, and this works for any powers, right? So let's say it's a power n and b power n. So I can generalize this as dx by a by b power n into b n plus n. If you closely look at it, these two terms are literally the same, because it's going to be b power negative m, and you're again going to get b power n. So let us similarly do this. And why do I do this? It's such that I can get an integral of the form f of x into f dash of x, and that's something quite easy to simplify later on. So let us solve this using this trick. So integral dx over, for instance I'm just going to do x minus 1 over x minus 2 and show you how it's actually done. Well, let's do x minus 2 over x minus 1. Right. X minus 1 to the power half. And this is going to be x minus 1 to the power b, just because I want to make sure that my b is right and I do not run into any other issues. So once done, I'm going to get b minus half equal to our term here. What's its desired to be? 3 by 2. So that's going to be equal to 3 by 2. And b is actually 2. We're going to get 4 by 2, right? And b actually turns out to be 2. Fine. So let's stick with it and continue the problem. So integral dx over x minus 2 by x minus 1 whole to the power of half into x minus 1 whole square is our required integral. So what I'm going to do here is again our good old substitution method and substitute this fraction term we've gotten as t. So dx over t to the power half into x minus 1 whole square. Now as you might see, this term looks quite bad, right? We have a t here and we have x here, and it's with respect to x. So let us convert all our terms into parts of t such that it looks quite better. And you witness magic, right? So x minus 2 over x minus 1 dt. So for the ones who don't know, derivative of v by u is equal to vu dash minus uv dash by v square. As earlier discussed in the video, v dash is actually the derivative of v, right? So similarly, u is our x minus 2 here, and I'm sorry, v is our x minus 2, u by v here. So u is our x minus 2 and x minus 1 is our v. we fix this u and this is v. So yeah, so x minus 2 is our u and x minus 1 is our v. And let us substitute this into our formula. So v is x minus 1 and derivative of x minus 2 is going to be 1 minus x minus 2. The derivative of x minus 1 is again going to be 1 over x minus 1 whole square. So let us substitute this whole times dx is actually equal to dt. So integral of dx, I'm sorry, not dx, dx will be opposite of this. So dx x minus 1 minus x plus 2 over x minus 1 whole square equal to dt. So this cancels out and we get dx equal to dt into x minus 1 whole square. Now that we've gotten this, let us put our beautiful dx term into our main integral. That's right up here. So integral dt into x minus 1 whole square over x minus 1 whole square into t power half. So isn't this interesting? We are able to cut out the x minus 1 whole squares and we get integral of dt by t power half. That's again going to be integral of t to the power negative half, and using our formula we're going to get it as 2 root t. Substituting our t into the main answer, we're going to get 2 under root x minus 2 by x minus 1 plus our legendary constant of integration, and this is our answer. So just to sum up a little bit what I've done here, we had a quite ugly denominator that we simplified it by taking the terms common and taking the whole term, that is the linear by linear, as a variable u or t or any alphabet for that matter, and then expressed it in terms of dx, and we were able to see that we were able to develop the solution quite properly after using the u by v rule. And yeah, that's about it. And this can be used for any questions which have dx over a power n into b over n. So let us just revise what formulas we learned today. So if we have any equation of form t square minus 3 which is not simplifiable using the lambda d by dx form, we can always express this in terms of 1 and the formula I've said earlier. And that's about it. Thank you.